we're going to look at the second factor which leads to loss of signal in optical fibers now, which is dispersion. So in very simple terms, dispersion is basically the slowing down of a wave of light. So the basic idea is at your source you are going to shine a wave of light onto an optical fiber. A wave or a beam, both are interchangeable terms. And what is it made up of? It is made up of individual rays of light, right? So at the end you want to get back this beam as it is, exactly the way it was when you modulated it onto the fiber. That is the target. But what happens is, due to different reasons which we'll be looking at in a minute, each of these individual rays travels at a different speed. So in the end, your wave, some of the rays reach there very fast, the others reach pretty slow. So, and you cannot say you've got back complete information until you get back the very last ray. So because some rays slow down, finally your information receiving is being slowed down. So that is what we mean by dispersion. So we'll look at it in detail and we'll understand now. So there are, so broad overview of dispersion is change in phase velocity with wavelength, which is a sort of high level definition. In simple terms, it means the velocity of each ray changes. And what do you mean by phase velocity? When I say different rays, how do you differentiate between them? Is each of them has a different phase. So for each phase the velocity is different. So ultimately they all do not converge at the same point at the destination at the same time. So that is what we mean when we say the ray has slowed down, or that is what is meant by dispersion. So there are three main types of dispersion: intermodal, chromatic or intramodal, and waveguide. We'll be looking at each of them in detail now.